Welcome to the Dapr community call, February 9th. Glad you can all be with us. We have a few topics to cover today, and then of course we'll have some time for open discussions, for questions, for proposals, for thoughts. I think today especially we're interested in feedback on the recent release candidates for Dapr version 1.0. I'm going to start with covering a few things that we actually covered in the last community calls, the previous one 2 weeks ago, but just to kind of refresh everybody's memory, and if you weren't around, just what is the plan for version 1.0. Then Yaron is going to cover running Dapr with Istio, which is a thing I think we're getting a lot of questions about service meshes and how they work with Dapr. So I think that's going to be a great demo to see and kind of hear how those work together. And Artur is going to show us some of the observability stuff around using the Java SDK, specifically the context tracing. And as I mentioned, we're going to have some open discussion. So again, whenever somebody's presenting something, feel free to ask questions in the chat. We'll try to address them right then. But if we don't get to you, we'll try to do it again at the end of the session. So let's get started. So as we shared last time, we're going to be announcing the version 1.0 next week, actually. It's really, really exciting. February 17th is the day we expect to make the announcement. The announcement will come in the form of a blog post on the Dapr blog. Hopefully you're all watching that. That's where we have a lot of our announcements and some great content. And that will be, of course, followed with some tweets and some other activities that we want to put out there. And we'd love for the community to help us spread the word. Of course, you have all been a part of this release, and this is a community effort. So this is actually a kind of a celebration for all of us, but also kind of taking a moment to even a little bit boast about it. I think it's really a great milestone. So feel free to, on the day of, share the announcement wherever you think is most appropriate, Twitter, Facebook, wherever, and whether it's retweeting or just your own tweets or posts. And feel free also to write your own content. I think a lot of this is hopefully going to create some really good awareness for Dapr. And a lot of people are going to be discovering it for the first time. So I think there's always need for, whether it's getting started material or just a scenario you're using Dapr or things you think are cool, or even if it's like a niche topic, I think it's really, really cool. Artur, a few weeks ago or even a couple months ago, did a blog post about running a Raspberry Pi cluster with Dapr, which was really cool. So all this stuff is welcomed. We actually had Harry, who's on the call now, I saw, do a great post about New Relic. Harry is from New Relic, so it's kind of a cool thing that we got somebody from there to show how Dapr works well. And even Xavier we're in the process of writing a blog about his experience. So some of this can come on the Dapr blog and reach out to me, but honestly, we'd love it to do it. If you already have a blog and you want to share some stuff, let me know. I'll help promote it. And we'd love to see more content out there. There's a lot of stuff going on. There's even a Dapr book coming out that's going to be really released in February 17th, I believe, Mark, right? Dapr for .NET developers, just a free PDF file that you can download. So that's going to be really cool. Yeah, and in terms of if you are looking to so what are we telling people to do? We want them to check out the docs. The getting started experience is really a great way to get started, to install the CLI, do a Dapr init, try a few things, and then it kind of directs you to the quick starts that hopefully people here are aware of. So that's a great thing as a call to action. And also we have a nice explainer video if you've seen, and I know we might have a few videos coming up as well. So just watch out for all that content, and we'd love to get your help to spread the word. So yeah, so I don't know if there's any questions on that. I'm just seeing a lot of whoop whoop and looking forward stuff in the chat, which is great. I'm also excited about this. But yeah, if not, then let's move on. Yaron, if you're ready to
Yep,
start,
I
you can
am.
stop sharing. You can take the helm.
And let me share my screen. Was that intentional? Take the helm, Ori?
Oh, sure. Yes, exactly. It was very intentional.
Okay.
We can
I
see
will
it. Yeah.
a little bit about helm now. Can you see it?
Yep.
All right, cool. So today we're going to talk about Dapr and Istio, better together. Insert any other catchphrase that you want. And Dapr and Istio, in some circumstances, can be a really great love story as long as you configure them correctly together. Because if you don't, that love story can very quickly become a hate story. So I will show how we can enable Dapr and Istio together, and then I'll show an application running in that configuration, and we'll talk about some of the stuff that Dapr has that the Istio also has, and maybe when to use each and one of those features, and then we can just open it up for discussions. So without further ado, this is what we're going to be showing today. I'm just going to be taking a very simple Dapr quick start and running it on Kubernetes. And this is gonna basically show a Python app that's using Dapr service discovery feature to discover a node application running in the cluster, sending a message to it, and then that node app will call back to its Dapr sidecar and save the state to a Redis state store. Now, it's important to note that Dapr has its own MTLS connection feature, but for this exercise, we're going to install Dapr without TLS and actually let Istio take over. And this is what we're going to see today. So we're going to have the Python app still talking to Dapr, but then because it's a plain text connection, Istio, which is really Envoy running here, and the reason why I don't have the Envoy logo is because I couldn't find a transparent Envoy logo on Google. So we have the Envoy proxy here. It's going to intercept the traffic using IP tables, and then Envoy is basically going to send the connection to the target Envoy proxy over a TLS secure connection. And inside of the pod, that'll get forwarded to Dapr and then to the node app unencrypted. And we should expect Dapr to be able to save the state into Redis here. Okay, so let's see how this works. I'm going to be installing a bunch of stuff today, but we have time for that. And I don't have Dapr installed in the cluster. I'm going to be using the Dapr CLI and the Istio control CLI. So I'm going to do Dapr status. Yeah, there are Zoom messages coming up. Dapr status -k. And we can see that Dapr is not initialized in our cluster. So I'm going to be installing Dapr. And I'm going to be using the latest RC release. And the important thing to note here is that I'm telling Dapr not to enable mutual TLS in my cluster because we're going to let Istio do that. So I'm just going to kick this off, and I'm installing Dapr with the Dapr CLI. And that's because unless I absolutely have to use Helm, I personally won't use Helm. And so I'm using the CLI to install it. I don't know if you've read the release notes for the latest CLI, but actually you can take all of our Helm configurations and just pass them through with a --set command to the CLI. So you get all the Helm configuration with the Dapr CLI without actually having to have Helm installed or using Helm. So this is now finished. And we have Dapr installed. I'm going to do Dapr status -k. And we can see that the Dapr control plane is up and running. Everything's healthy. This is basically what we want to see. We can see that it's running the latest RC. And so the next step now is to install our quick start sample and validate that it's working. So I'm going to hop over to VS Code here. And we have this Node Python example here. I'm just going to review it ever so quickly. So this is a Python app that's just sending a request to its local Dapr sidecar, asking to invoke an application with the ID of Node app, and it wants to invoke the new order method, and it's just sending a JSON payload here. So pretty simple, and it's looping. And the Node application, if we take a look at it, it's right here. is a very simple Express app, no special packages or anything. This is the new order method. So Dapr will send a request to this route, and then the application will call back into Dapr and save the state. And if it's successfully saving the state, it'll just print a console log for this. And then it also has another endpoint for getting the order. And we're going to use that later on when we'll try to validate if Envoy and Dapr are actually doing their mutual TLS dance together. So this is the sample app. I will go into the Hello Kubernetes and deploy directory here. And I will start by deploying the Redis component for Dapr. So this is just the component that tells Dapr about the Redis instance that's running in the cluster that's going to hold the state that the Node app is writing. And the component has been created. So I will just apply the Node app and the Python app. So now we can go here and we will wait until our applications are up and running. And they are. And if everything is working successfully, we should be able to log from our node container. And yeah, we can see that everything's working. We're successfully persisting state. Now, how do we make sure that Dapr has MTLS disabled in the cluster? We can just do Dapr MTLS-K, and the Dapr CLI will just tell us in a pretty easily understandable English phrase text here that mutual TLS is disabled. And this is a pretty nice thing because some other technologies don't necessarily give you that information so easily. So we know that we don't have mutual TLS, and we can now proceed with installing Istio. So what I'm going to do now is basically use Istio cattle, which I downloaded from the Istio website prior, and I'm going to be using Istio 1.8.3, which is the latest release, and Istio 1.9 is currently in RC. And there is a bunch of nice stuff that's going on there. All right, so let's install Istio. And Istio also is sort of, I wouldn't say maybe moving away, but it's also giving a lot of possibility to install, sorry about that, not using Helm, but actually using the Istio cattle. And let's do Istio cattle install. And I'm going to be using the demo profile here to install Istio. And what this basically means is that we're not going to have high availability running for Istio. It'll just make it a lot quicker to install. Otherwise, Istio just installs a whole bunch of stuff, and we don't want to wait that long. And so we will wait a few seconds for Istio to finish. Yeah, and this is done. So the installation is complete. And now if we roll out, restart our deployments, we should actually see the Envoy proxy here. So let's do a rollout restart for the Node app, and let's do the same for the Python app. Put a watch. And now we can actually see that we have the Istio init container here configuring the IP table rules that are needed. And we actually now have 3 containers running inside of the pod, which is our application container, the Dapr container, and the Envoy proxy all running together. So yeah, everything's up and running. Let's see if we can still see if our application's running. So I'll just take the new pod name here and print that out. And yes, everything is running correctly. Now, does this mean that we have MTLS enforced at this point? Well, yes and no. It's not necessarily what you'd expect. So by default, yes, it's true. Istio and Envoy give us mutual TLS by default, but, and there's a big but here, it'll also allow text plain connections. And so if we really want to have a strict TLS policy, we need to explicitly tell Istio to do it. And just to prove that that's the case, we have the Redis container here. And I'm going to be executing inside of this Redis container and opening up an interactive terminal with Bash, and I'm going to try to invoke the Node app. So if strict MTLS is enabled, we should get a connection peer refused message, and we should not actually be allowed to do that. So let's see if that's doable. Let's do kexec. So I'm opening up bash session and I'm currently inside of the Redis master container here. So the next thing we need to do is get the IP address of that pod so that we can try to connect to it. So I'm going to do kubectl get pods, and I'm going to print out the IP address here. And if you remember, we have the order method inside of our Node app. So if I go back here, we can see that we have the order method. So I should actually be denied access now if MTLS is strict. So I'm going to do curl, and I'm going to put that here. And we're listening on port 3000 for our application. But you can actually see that we are getting the order back. So Envoy is accepting TLS connections from other Envoy-enabled sidecars, but it also allows text-plain connections. So what do we do to make it strict and make sure the Dapr is actually running correctly? We have a policy here, which is what you'd apply on a namespace if you want to create a policy for strict mode. And this is the Istio policy to do that. So this is going to be namespace scoped, which means that this is going to create a policy where every Envoy-enabled proxy pod in the cluster will require connections to be TLS enabled, and it'll just deny text plain connections. So we will just apply this policy here. And it has been created. And at this point in time, we can just exec back into the container, and we'll curl it again. And we can see that now it's operating correctly. The requests are being denied because we're trying to access an application where Envoy is running over a non-TLS collection. But is Dapr still actually running correctly? So let's go here and take the Node app, and let's see if we're still getting requests coming in. And we can see that Dapr and Istio are all running nicely. And this is basically it. So now we're running Dapr with Istio, where Envoy is doing the mutual TLS, and Dapr is just doing its thing. But our application can still call using Dapr to the state store, and we can still get service-to-service invocation and Dapr service discovery running, but Envoy is doing the TLS. And that's basically it for this demo. So let me go back here and let's talk about some overlaps that Dapr and Istio have. So the major overlaps are mutual TLS because we've disabled MTLS for Dapr, but Dapr does have its own mutual TLS connection here feature for service-to-service invocation. So when I said in the beginning that it's a love-hate story, if you try to enable Dapr's TLS with Istio, bad things are going to happen. Now, if you really wanted to do that, you could, because actually Dapr and Istio both use Spiffy, which is an identity framework standard for workload identities. So both of them use it. So if you configure Dapr to use the Istio root certificates, or if you enabled Istio to use Dapr's root certificates, then you could actually have both of them doing the mutual TLS. But then again, I personally don't find any reason to do that. If you do, please write in the chat, or maybe we can talk about it. But basically, if you're running Dapr and Istio, not just Dapr and Istio, but really Dapr and any service mesh together, you probably want to only let one of them do the mutual authentication for you. The next area of overlap is really about tracing, because both of them do tracing. Now, the reason why I specified partial overlap here is because Istio will, and any service mesh really, will only trace stuff that's occurring inside of the mesh, right? But if we go back here, for example, and imagine you have a Kafka queue or an AWS a Kinesis stream or an Azure Service Bus stream or whatever that's invoking our application. So that's actually not traversing through the mesh. So you will not get tracing for it by default. Because Dapr has all of the connections going through it, including event-driven ones, it'll actually create a holistic tracing map for you. So for example, if you used Redis both for state and pub/sub, and we'd had this Node app subscribing to events from this Redis stream, Dapr would actually know how to connect those together, even though the connection didn't necessarily traverse through the mesh. So this is a major difference between Dapr's tracing and the service mesh tracing. And lastly, we have metrics. So both the Dapr sidecar and the Envoy proxy, or Linkerd's Linkerd2's proxy, if you're using Linkerd, will emit proxy. You get stuff like number of concurrent requests, gRPC connections, maximum bytes received, all of the golden metrics that you really need mostly for doing stuff like auto-scaling decisions and to monitor the load on your traffic going into your application. So Dapr has a bunch of those, and it pretty much overlaps, I think, with the golden standards that metrics that service meshes give you. So, you know, you can have both. I mean, it's really nice maybe to have both of them sending metrics, because you might want to monitor the Envoy proxy and Dapr separately, and you might decide to use one of them to actually see, you know, for example, what's the response rate for your application if you're using Dapr service invocation, for example. So you really have this ability to choose which metrics you want to use from each one of them. And that's it. So I'm done with this. We can go into the discussion phase if there are any questions here.
Yeah, I see a couple of questions. Thank you, Yaron, for the demo. I see a couple of questions on the chat. One is from Sasha. Yaron, apologies if I missed it. Is the peer authentication and Istio injection enabled specified on the Dapr system namespace too?
Yes. So I have the Istio label there from runs that I did prior to that. That's why I didn't show it here. If I didn't have the injection enabled label on the namespace, you wouldn't have seen the Envoy proxy get injected.
Okay, thank you. Another question from Monty. How many service meshes will version 1.0 support?
It's not really about Dapr supporting service meshes. And that's a good question, by the way. I mean, I think we do need documentation about the service meshes that we know that Dapr works with, right? So if that's the question, we've already shown how Dapr works with Linkerd in the past. I know people who are running Linkerd and Dapr together, and I also know people who are running Dapr and Istio together. So for 1.0, you know, we can safely say that Dapr can run with Linkerd and Istio. One service mesh that Dapr doesn't run nicely with today, and that's a point in time thing, is Open Service Mesh by Microsoft. There is an open issue on Open Service Mesh, and that's because Open Service Mesh generally doesn't allow you to work with pods that have more than one application container. So you have to have one app container and then the Envoy proxy, and that's basically it. So if you're running Dapr there, it'll fail because there is some issue with health checks probes. But again, Dapr works pretty well with Istio and Linkerd, and I expect that to remain by the time we release 1.0.
Okay, cool. Thank you. There's additional. Oh, is ASF still on the radar?
That's Azure Service Fabric. So if the question is Azure Service Fabric still a target for the radar? Yeah. I mean, yes, it's one of those platforms that we still consider targeting. We've focused on Kubernetes as the one for production for this V1 release, but yeah, please send us your scenarios. We really wanted to kind of know the scenarios around these things. You can run parts of service Dapr on Service Fabric, like the pub sub will work fine. It's just a service invocation piece where you need to actually integrate with the underlying platform itself. In the case of Service Fabric, that's a naming service.
Okay, so if there's no additional questions, Artur, if you want to present, you can go ahead.
Let me share my screen. Okay, I'm assuming you can see my screen.
Yep.
Yep.
Okay, so you can see this issue here. So we had some changes in the Java SDK recently, and there's one of them that I like to show in this demo for the community. So the Java SDK was using the OpenTelemetry SDK and relying on its context object to do tracing. So so that what basically happens is that other apps that use the Java SDK, we have to depend on the same OpenTelemetry version that we do, and any breaking upgrades for OpenTelemetry, it would break other apps as well. So we decided to don't have this dependency, remove it from our dependency list, and also remove the context from our objects. So there was another issue here where we would remove the context from our domain objects and just rely on the mono from Project Reactor context. So I don't know if there are many Java developers in the call, but that should be familiar to Java developer these days using the Reactor framework, and that's what we use on the Java SDK. So, and folks that use .NET are going to appreciate .NET's async and await after this presentation, just as a side note. So I'm going to demo how we do tracing now going forward with the next release. So you can deploy Dapr as usual. Okay, have the SDK, go to the examples, install Dapr. The example will basically start an application on a port. We're going to use a Spring Boot, and we're going to have two events. One that will simply echo a message on the console, a very simple echo controller. And there's nothing specific here to Dapr or OpenTelemetry. There's no code change needed at all on the app on this part. And another one does a sleep. Same thing, the usual implementation for a Spring Boot REST controller here. And in this case, just Spring. So we can run this, but I'm going to skip the run for now. And then we have another controller that we basically just proxy the calls. So we use the Dapr client that is injected and going to invoke a method. Okay, just invoke the method into a separate app, just so we can have a little bit more complex stack trace to demo. So, and then we proxy the sleep call. And this uses the method invocation feature in Dapr. And now comes in the tracing part. So if you use OpenTelemetry, which now is not required anymore, it's just a decision of the app developer to use the OpenTelemetry SDK. In this case, we stick to it in the example. So you have to handle the header from the HTTP call on the server side. So this interceptor is a handler interceptor in Spring. And we have the pre-handle logic that we basically parse the headers into a context and save that context in the request attribute, okay? That's typical thing for folks using OpenTelemetry today. The difference now is that when you're using Dapr, we expect you to use the get reactor context. So in this case, the app has to convert the context from OpenTelemetry to reactor context. And this is an example of how the app can do it. It's basically mapping a hash map from one entity to another. That's what it does in the end. And here we're using the OpenTelemetry SDK to do that with the propagators. So that's language very specific to OpenTelemetry. And in the end, we take this hash map and put it into a context for reactor. And as you can see, it's just a translation. This is used, for example, when in the proxy method, we use the subscriber context here to make sure that the context is propagated and we don't lose the tracing headers in the middle. So, and the same thing for this other method. So you prepare the chain of invocation where you invoke the method, but before you subscribe to it, you set the context. So that's the logic that this is doing. That's why this has to happen after, not before you prepare the call. Okay. And by the way, if you're not familiar with Project Reactor, no invocation happens until this chain of events is subscribed to. So this is just a way to concatenate things. It's a little bit different of how you code with Project Reactor. And then in the client side, we simply do the same thing. where we call the methods that we want, and then we call subscriber context, get reactor context. And in this case, we make a blocking call just because it's a console app. We don't want to deal with asynchronous processes, so we just make a blocking call. So if you run this, let's go from the first command. So I can run this now. And this demo is very Java specific, so it's probably for a Java audience. So we run the Spring app, in this case, Spring Boot. And we're going to run now the middle service, the one that you're just going to proxy calls, so we can have a more interesting stack trace to look at. And finally, we run the app. Okay, makes 2 calls, and then it's done. And now, if we open the Zipkin endpoint and run a query, we should have one that was done a few seconds ago. And you can see the stack trace correctly, including the proxy calls. Okay, so that was the demo that I wanted to show. This is a breaking change. It means we don't have the context anymore in the object, and we don't have dependency or OpenTelemetry SDK. In the SDK is a choice of the app, and we are relying on Reactor to propagate the context going forward. That's what I had to demo today. I'm going to stop sharing. Any questions?
Thank you, Arthur. I just saw a question about Jeroen's demo, actually, from Sasha. That Jeroen said he's going to reference, but
he brought a great point. So I'm going to be sharing again, and let me know when you can see it.
You see it.
All right, great. So Sasha, you were asking before whether or not the Dapr control plane actually has Istio enabled. So first I wanted to show that it does. So if we take a look at the Dapr system namespace, the operator placement and Sentry pods are running the Envoy proxy. And about the error that you mentioned, that's about the sidecar injector, right? So the difference between those Dapr system pods and the sidecar injector is that in terms of a mesh, the Dapr sidecars talk to the operator. They might talk to the placement server, you know, if you're running actors, and if you have mutual TLS enabled, they will talk to Sentry. And that's why I configured the Envoy proxy inside of each of those pods. The sidecar injector, on the other hand, is not contacted at all by the Dapr sidecars. It's contacted by the Kubernetes API server. So if you're injecting Envoy there, the error that you're seeing is because it's stopping the Kubernetes API server from reaching inside the sidecar injector when the admission request comes through. So this is not a request that's filling from Dapr. It's actually filling from the Kubernetes API server. Now, Dapr and most projects actually use sidecar injectors. We have a TLS connection already enabled because during the installation for Dapr, we have a TLS certificate that's getting created, and it's getting configured for the Kubernetes API server to authenticate itself with the Dapr sidecar injector. So you don't necessarily need an Envoy proxy there. In other projects where you don't necessarily have a certificate, you need to create an Istio rule to basically allow the Kubernetes API server service to reach out into the pod itself. So this is an Istio setting that you need to make. I hope that answers your question. By the way, you can or you can unmute him if maybe he wants to talk.
Yeah, sure. 1 second. Sasha, I think you can unmute if you like.
Perfect. Yeah, can you all hear me okay?
Yeah, sure.
Yeah.
Great, yeah. So it's essentially, yeah, very similar to what we set up. So I take it you've annotated the sidecar injector and the dashboard deployments with the what is it, the Istio injection disabled annotation specifically for those. Because that was one of the key things we observed. The other side I think might be useful for the community is how it works in relation to ingresses as well. Because what we noticed was obviously within the cluster, you can have obviously the strict MTLS enabled between Dapr system namespace and whatever pod namespaces you might have. But then you've got the additional namespace, whether you're running the Istio ingress gateway or the Kong gateway, Nginx, whatever it may be, where there's another layer. Now, I obviously that is probably outside the scope of the Dapr one, but obviously for a demo, it would be useful to demonstrate, or at least in the docs, demonstrate the end-to-end, because that's where we've certainly seen a few funny things come up, not so much from the Dapr side, but with Istio plus Dapr. The other one we observed was it might have been in it was an RC2 where we had to inform Istio to hold the application until the proxy starts. Because obviously for those who don't use Istio and Dapr both sort of inject at the first point in the pod, inject their containers. But if Istio injected before Dapr, it would end up blocking Dapr. So what we ended up having to do was tell Istio to basically not start up until everything else was. But I don't know if you came across the same.
Yeah, that's a great point. Actually, I personally didn't encounter this, but this is a really good point. And it'd be really great to have documentation about how to run Dapr and Istio, and we'll be really grateful if you can help us do that. Sasha, are you there? Am I muted?
No, we can hear you.
Okay.
I think he muted and then he needs to be unmuted again. That's how it works here. But so let me do that. Yeah, sorry.
Hi, sorry about that. Force a habit on Zoom calls. So yeah, no, we are definitely we're putting together as much documentation as we can, which we'll hopefully share with you guys in terms of our journey with Istio. So in essence, our application we're building with Dapr is microservice product service mesh. So we're building it with Kong plus Istio and Dapr, with all of them theoretically running in strict MTLS, and we're currently working our way through it, but we'll definitely post our experience with Istio and Dapr, which has been a lot more seamless. Where we found certainly a lot more challenges was with the ingress controllers. Getting them to work properly has been particularly troubling, but that's not so much the Dapr, that's more Istio.
All right, great, thank you. We'd love to see that documentation when it comes out. And feel free to reach us over Discord. We'll help with whatever we can. Yeah, and it's great to hear about what you're building with Dapr. Thanks.
Yeah, amazing. I just want to kind of reflect what your own is there. If there's anything you can do just to help get the simple Istio guidance, we'd love to just see it, and we can always build on it from there.
Absolutely, that sounds fantastic, and thank you again for answering. I know you've had a lot of questions from myself and my colleagues, and thank you for answering them all. Like I say, we're as keen as you are to get. We're going to be rolling out Dapr very much as early adopters in production in our system, so we're definitely keen to write as much documentation to assist as we can.
Amazing to hear. Thank you.
Okay, with that, let's open it up to anything really. Any questions, any comments, proposals? Definitely feedback on the recent release candidates if you've tried them out, specifically the RC3, but even other ones. Okay, if there is no additional topics to discuss, thank you for coming on the call. Again, next week is a really exciting time for us, the release of version 1.0. And I think as a community, we should all be very proud and very happy with what we're delivering. So thank you to everybody who contributed and is coming on this call and bringing so much value to the community. Thank you very much. I hope to see you again in 2 weeks.